Hello, here's a brief biographical background of Georg Ohm, the German physicist and mathematician, of course, most famous for discovering Ohm's law, or at least having it named after him. I'll get back to that later on. Um, Ohm, he was born in Erlangen in Bavaria, so we're looking at southern Germany as we'd see it nowadays. Of course, back then, this was before Germany became a unified country, so this was part of the Holy Roman Empire. But still, we're in Bavaria, we're in the south. He was the son of a locksmith, and his father was self-educated in quite a wide range of subjects, but particularly maths and science. And he taught his sons, notably Georg and his brother, who also became a mathematician. He was sent to Switzerland when he was relatively young, in his teens. He became a teacher in Switzerland when he was sort of 17, 18, so yeah, pretty young. And this was the start of a fairly varied career where he would slip in and out of being a teacher or a lecturer or a private tutor. He didn't stay as a teacher very long in Switzerland when he first started. He quickly changed to being a private tutor while continuing his own studies in maths. He then returned to Germany in his early 20s, briefly lecturing in maths at the university in Erlangen. And But then he went back again to being a teacher and more private tutoring and such like. A lot of these changes were driven by difficulties with the pay, whether he was going to be earning enough money just working at a university rather than doing private tuition, but also some issues as well with the way that the state was run in Germany at the time, and the competition for getting the more prestigious, the more better paid jobs. To that end, he started writing a geometry textbook. And once he had completed that and sort of improved his standing with the government at the time, he was then promoted to a school with better lab equipment, better pay, and such like. And it was in this period, in his late 30s, where he made his major contribution to physics. So this was his work, which he named, well, in German, but this is the English translation, the galvanic circuit investigated mathematically. So galvanic circuit. So this is named after Luigi Galvani, him of twitching frog leg fame. So galvanic circuits is really just talking about electrical circuits, but that's what they were often referred to back in the day. And that included his statement of Ohm's law. So this was the first published statement of Ohm's law. He started off investigating this using voltaic piles. So it wasn't that long after Alessandro Volta had done all of his work. Volta was about 40 years older than Ohm. And Ohm started using these voltaic piles. He quickly switched from those to using thermocouples because thermocouples are more stable. If you've ever tried creating your own voltaic pile, which is relatively easy to do, it's not that easy to get a definite and constant voltage from them, at least using sort of primitive techniques. As we would see them nowadays. So he switched over to using a thermocouple. So this is where you're getting a EMF from a temperature difference inside a metal. And that is much more predictable, much more stable in terms of the voltage that it's producing. So that's what you want if you're going to be then investigating the change of current with voltage, which of course is the foundation of Ohm's law. His empirical findings, though, they weren't that well received initially. The German state was still rather Aristotelian in its scientific approach. If this idea that if nature is well ordered, then who needs to do experiments? You can just think about things theoretically. You can sit there and unpick the ordered nature of science and the universe. But it didn't take that long before his findings found acceptance. The scientific community more widely was lapping this sort of stuff up, and empiricism was certainly the order of the day, even if it might not have been amongst some of those in the education departments of the German state. Of course, Ohm's law is often misunderstood nowadays as just being any kind of statement of V equals IR, rather than the necessity of R being a constant. This is where we're getting the idea of ohmic and non-ohmic conductors. If we're drawing out our IV characteristics of different conductors, then whichever way round, whether we're doing I on the y-axis or the x-axis, our ohmic conductors, our Ohm's law is saying we've got this constant R. So we've got that I is proportional to V, and then R is this constant that's going in there to turn that proportionality into an equation. So although V equals IR is something that we can apply in a much wider set of circumstances, the idea that we've got a constant resistance in an ohmic conductor, that is what is characterizing Ohm's law. Now, as I mentioned before, of course, Ohm's law is named after him. He's credited as certainly as being the first known person to publish Ohm's law, and is then credited as discovering it, and then it has it named after him. But Ohm's law was discovered earlier, but not published, by Henry Cavendish, who I've mentioned in previous videos in the classical mechanics section. Cavendish is the guy who discovered hydrogen, and from a physics point of view, he was the one who conducted the Cavendish experiment, which is the one that allowed him to determine the density of the Earth and thereby determine the gravitational constant, our capital G, that we've got in Newton's law of gravitation. Now Cavendish, it turns out that he did discover this before Ohm, but Ohm published first. It was named after him. People knew that Ohm had come up with his first, so he was the one who got the credit. There's loads of instances of people having laws named after them when they weren't the ones who actually discovered it first, but sometimes you just got to be right place at right time. And this shows that it isn't always a case of Eurocentrism as to who gets laws and theories named after them. Sometimes that may well be the case, and sometimes it's just people aren't aware of what has come before them. And so when you get a lot of these cases, whether it was stuff to do with the Islamic Golden Age or some of the early discoveries in the scientific revolution, sometimes they didn't get these laws and theories named after them, but it also happened later on, as we see in this case here with Cavendish and Ohm. But there you go, there's a bit of background on Georg Ohm.